Alright, now we're going to try to get some more parts out. Let's see, this one unscrews. Oh, that's interesting. These things are bent that way, I guess, so they lay flat when you screw them down. To figure out which screws allow me to pull the amplifiers out. Try not to lose any parts. Probably have to take both of these out. You always have to be careful about wires that are connected, so carefully pull this off. And power wire here, and there we go. Got an amplifier pulled out. We want to be kind of careful if we haven't, or if this has been turned on recently, because these capacitors here can hold a mighty charge. So we're going to want to try to short those out, just in case there's anything left in there. Of course, I don't see any sparks, so that's good. Might be hard to short some of these out. We'll have to try to find a way to do it with a wire, maybe. But I'm sure they're fine. I haven't had this thing turned on in a long time, so these guys are electrolytic. That means it has a liquid inside that dries out. There's a rubber stopper on one side here, the black part, and that can allow that liquid to escape over time so that it dries out. So this one we're going to have to replace. This one we're going to have to replace. Let's see what these are. So this is 20 MFD. That means microfarad. The farad is a unit of charge. And this guy hopefully is the same, but it might not be. Yep, 20 microfarad, 300 volt. Surge 350 volts. So we have to find a capacitor that's rated at least 300 volts, 20 microfarads. 300 is the maximum voltage that capacitor can handle before it blows up, literally. This one can handle 350 volts for a short time, but they recommend 300 volts typical. So we want to get one that's at least 300, maybe 350, maybe 400, depends what we have. This one here says, hard to see, but see if I can get in here. It says 20 plus 20 microfarads, 350 volts, surge 400 volts. So they've marked these, so black is negative, red is positive, red is positive. There's two capacitors in one package in here. They're both 20 microfarads. They're both rated for 350 volts. I'm going to assume that this thing's not working very well either, and it's best to take it out of the circuit completely. We can leave it there for looks maybe, and then there's not a lot of space to add other capacitors in here, but we could just pull this whole thing out and replace it. That's probably the best thing to do, and replace these also. So the nice thing is they're all the same 20 microfarads. So if I have a 20 microfarad 350 volt capacitor, I can just put 4 of those in here and clean that up nicely. I see another one down here, this little silver thing that's going to be a pain to get to, but that says 1 microfarad 150 volts. That's another electrolytic one. I can see the rubber stopper on the end. We're going to have to replace that. And then there's 2 more here and here. I can tell by the aluminum can. I can't see the rubber because it's on the other side. This one is 25 microfarad, 25 volt, so it's a low voltage capacitor. And this one's probably the same. Kind of dusty, it's hard to see. Probably the same. I'll have to check it when I pull it out. They look the same, but that doesn't mean they're the same. There's another one over here, 25 microfarad, 25 volts. So we're going to replace those 3. And there's a fourth one off to the side in here that we're also going to need to replace. So I'll look for that and see if I've got those in stock. I believe I do. The value likely is not that important for those. And I found another one here. This is, well, actually, let's see. This one might not be electrolytic. It looks like it's a really low value. It says 005, which would be 0.005 microfarads, which is the same as 5 nanofarads. That's not going to need liquid to get a capacitance that low, so it's probably fine. It just looks like electrolytic because it's got plastic shrink wrap on it. And there's a bunch of those here. They're probably okay. I'm going to target the big ones first because those are the ones that dry out the worst. These guys and the silver ones. So let's see what I've got. Here's my tub of capacitors. Let's see what we've got. Alright, these guys are made in Japan. That's awesome. It kind of follows the theme of stuff made in Japan. 22 microfarads. Probably hard to see that little symbol there because the camera doesn't want to focus, but it says 22 microfarads with the Greek letter mu and 350 volts. Now, if you're paying attention, you would say that those are way smaller than this. So the question is, what's wrong? Why are these so much smaller? Nothing's wrong. This is just newer technology. They pack more charge into a smaller space. So we need 4 of those for the one amplifier, and I'm going to assume 4 for the other amplifier, so I'll go ahead and pull 8 of these out. I haven't pulled the other amp out yet, but we'll get to there. Luckily I got these for a steal, so these are incredible price. Alright, so we still need 25 microfarads, 25 volts. Those are going to be tiny, if I can even find them here. And there was a 1 microfarad, 150 volt. So let's see what we've got here. This is 1.1 microfarad, 350 volt. That's overkill. But those are very, very good capacitors. That's 400 volts, a little less than a microfarad. Also top-notch capacitors. Let's see if I can find any in the right voltage range. I'll look for those later maybe. Oh, these are super high quality styrene capacitors. They're probably just about the right value. These things are really expensive. I'm not sure I want to use them on quite yet. Maybe I will. If I knew exactly what the application was that capacitor was for, if it's in the audio path, I'd use these because these are fantastic. Very expensive. But if it's not an audio application, then I wouldn't want to waste them if it's just a power supply. 10 microfarads, it's a little bit bigger. I know I've got 25 microfarad or something like that in here somewhere that are really small. That's why I'm having a hard time finding them. Buried in one of these bags probably. I'll take a minute to look for that. Well, I found the schematic online and I'm trying to figure out where the capacitors are. So the capacitors are these 2 thick lines that look like an equal sign, sort of. So I'm looking at all these capacitors, and this one, for example, says C24, and then after that it has a 3. This one says C25, and after that it has a 20. So this 20 means 20 microfarads, and those are the ones that we saw back there. C25 is just the number of the capacitor. Right next to it is C26. Each one has a unique number, and that also has a 20, so we're going to assume that's 20 microfarads. And I'm looking at all these for a 1 after it, and I don't see any of them. This one says 20 microfarads, this one says 25, this C17 says 0.001, this is 0.01 microfarad, 0.001, but there's no 1 microfarad. The closest one I could find is, oh, here it is, C3, it's 1 microfarad. And I can look at this schematic and probably tell you that it's not going to have the voltage on it that I'm afraid of. The thing is, I found a really nice capacitor in here somewhere that I wanted to use, wherever they were. Not those. But these ones are 3 microfarads, 100 volts. These are really good caps, but it's only 100 volts, and the one in the circuit I can see says 160 volts. So I got to make sure that the voltage is low enough that a 100-volt capacitor won't blow up in there. So we don't want that to happen. So I'm going to turn it on and measure the voltage on that C3 there. And if it's less than 100 volts, I'm going to use one of these capacitors because these are really good caps. The other capacitors, that everyone marked 25 or 20, I'm going to go ahead and replace those with the 22 microfarad capacitors I have. And that will clean up most of the electrolytic capacitors that are probably all dried out. Okay, I got the meter here, got it set to 200 volts DC. This is going to be a little tricky because we have to hook up the circuits again, and that means we got to get the mechanical stuff hooked up again. Let's see, we need this plugged in, that's for sure, and that's all over here, so it's going to be a pain to get all this hooked up. Let's see if we can do it. Let's see, this guy goes here somehow. It only goes in one way, thankfully. It's got 2 fat pins, and it's hard to tell which 2 are the fat ones. So basically turning it around until I get it to line up right. I should have marked it with a marker. There we go. This guy plugs someplace. Where does this one from? I can't remember where I got that one from. Oh, maybe this plugs into the next amplifier. Let's see. Yeah, because this is the bottom and the wire's bent this way, so I know that it's supposed to plug into the bottom amplifier. Anyway, let's try to see if this powers up and see what the voltage is on that capacitor if we can. So I'm going to try to connect it right in there. And we need the power cord, of course. Alright, let's see if I can show you that. Doesn't want to focus. Alright, it's still a little hard to see down there, but got the red and the black clip on that little capacitor that says 1 MFD, 150 volts, or 150 volts. Alright. Okay, we're ready to try to turn it on now. I've got to figure out where that power switch is. Oh, got to plug it in first. I don't have the speaker plugged in, so we're not going to get any sound. Okay, there goes the motor. Not seeing any signals here. I'm wondering if maybe I need to connect more stuff. Or maybe I flipped that switch the wrong direction and its amplifier's off. Nope. Alright, we'll just have to try to hook more stuff up then. I can see the vacuum tubes lit up. Oh, here we go. 100 volts. Okay, so it's more than 100 at peak. And it's going down to where it will settle, which is less than 100. So actually 100 might be fine on that capacitor. Looks like it's settling around 70. Yep, 67. We'll have to reevaluate that once we get the whole thing back together again because the voltages might be higher. Okay, now the power's on, and if I turn it off, you'll see that the capacitors still hold charge, so it's very dangerous in here right now. And I shouldn't be holding a piece of metal with my right hand while I'm grabbing this with my left hand. But I do want to measure these capacitors, if I can very carefully get them apart, and see how much voltage is across these. So it's rated 300 volts. Right now it only has 187 on that one. Let's test this one. If I can get to it. Oop, it's more than 200. So I go to the 1000 volt setting, 242 volts there. Do not want to get shocked with that. All right, 276 volts on that one, and 285 volts on that one. So, so those numbers are pretty high. Watch as I turn it off. Let's see how fast it takes for those voltages to fall. And it's not that long actually on that one, so that's good. That's not going to shock you. 20 whatever volts. Let's check this guy out. 21. Check this one. Okay, that's only 20. 20. And it's going to be a pain to get to that little one in there, but it's probably fine. So, this thing's pretty safe to touch after a couple of seconds, so we don't have to worry too much about getting shocked. Alright, let's get to work trying to solder some stuff now. I'm going to start disconnecting this. Put this off to the side. I did find a bag of these are 47 microfarad 25 volt capacitors, and these were from a radio that I was repairing. Thankfully I bought plenty extras, so I'm going to use a couple of these to replace these aluminum metallic ones. These are 25 microfarad 25 volt. This is 25 volt rated, so the voltage is fine. It's about twice the capacity though. It's 47 microfarads. The purpose of these capacitors is, when I looked at the schematic, it's to stiffen the gain on the vacuum tubes so that you get higher gain. And so the capacitance actually doesn't really matter a whole lot, as long as it's high enough that low frequencies pass through it right. So this being higher than 25 microfarads is not a problem at all. So we're going to go ahead and replace all those with these. And I also have this, which these guys are 0.1 microfarad, 630 volts, so it's hardly any capacitance. But we're going to put one of these in parallel with one of these capacitors, and this will help block really high frequencies, especially radio waves, stuff like that, that interference you might pick up. And that'll help with some noise and stuff that we might pick up. So we're going to throw one of those in there too. Maybe two of them, we'll see. Alright, so we're going to be putting new parts in here, and the old ones have some pretty long leads, and they're axial, which means the leads come out the opposite sides. The new ones here are radial. The leads come out the same side. Always drop something on the ground. And so to stretch from here to here, I'm going to have these leads like really far apart. In fact, they're not even long enough. So I don't want to have all this exposed metal here. So what I'm going to do is cover the metal with the plastic from these wires. So I'm going to go ahead and strip some of this off with wire strippers. And I like to stick to red being positive, and in this case I'll use brown for negative. Usually black is the international, maybe not international, but it's the common color for negative. So at least when you look at it, you can tell which one's positive and which one's negative. If you put it backwards, your capacitor will blow up. So don't do that. Conveniently, capacitors are marked with the minus sign here on this side. The leg is also shorter on the minus side usually, but not always. These ones are marked with a big red plus on one side, so it's really easy to follow. Now if I'm a little bit smart, what I could do is just cut this thing here and here. I have to remember which one's positive, so I'm going to be really careful about that. and I can use the long lead to help bridge the gap here. Or yeah, so I'll do it that way. And I'm going to probably just cut this one out or desolder it. Let's see how hard it is to desolder. Let's put my iron on there. I've got the iron set to about 6, that's a little bit low maybe, let's say about 680 degrees Fahrenheit. I just got to sit it on here to get it nice and hot, and then the solder melts and it popped right out. Don't forget which one you're on here. Incidentally, I forgot something important, which is my rule: you always tin the wire before you use it. And all that means is you just put a little bit of solder on it first, and that makes it really stick well. If you forget to do that, you'll probably have problems with cold solder joints. So I don't think that went through a hole. Oh, there isn't a hole here. Okay. I thought there was a hole in the middle. There isn't, so what we're going to do is bend this lead into a notch to sort of wrap it around a little bit. That way it'll stick better. Let it cool, and oh, that didn't stick very well, did it? Maybe it didn't cool right. The other way so I don't have to bend it backwards. Let that cool a little bit more. Maybe I'll turn the temperature down just a little bit, 660 Fahrenheit. Okay, now this one I'm going to cut right up here. I can throw this out. Put that on there. The old wire probably should be cleaned up a little bit, but usually solder's enough. So again, pre-tin it. Just put some solder on there, and the flux in the solder, it just eats right through any junk on the surface usually. I'm going to grab my heat shrink tubing. I'll show you why. This is a kit of heat shrink tubing that shrinks around the wire when it gets hot. So I'm going to cut just a little piece off here. Cut it down so I don't drop it. And I'm just going to drop it over this one for now. We're going to attach these together with a quick solder joint. Both of them have solder on them already. They're tinned. Alright, now I can just slip this over top, and it's not going to stay there, but that protects that joint from touching anything. And I have a hot air gun here, and I'm just going to shrink that stuff on. So you see that shrink, maybe. And so now it's held in place. It's not going anywhere. So that capacitor is done. Now I move on to the next one. And do the same thing. Sometimes you have to sit on these joints for a long time before the solder really melts well, and then once it does, that's when you stick your part in. Make sure it's completely dry, completely cooled. We're going to have the same problem here about being able to stretch, so I'm going to cut this lead as close as I can to the capacitor itself. Tokyo, Japan, Nippon Chemical. This already has a covering on it, so I'll just snip it shorter. Can reuse that covering, no problem. And then we get our heat shrink. Actually, since this is the negative side, I'm going to use a black one just to be consistent, or blue, I guess, because blue is the one my finger grabbed first. use blue. Not a big deal. Okay, now we have to tin the original lead here. Next we'll try to get this guy on the top here. Alright, this one's got a couple wires hanging out of it, and you know, these things are so small that we can just stick a couple of them in here and just maybe even leave that cap there. The problem is this is screwed in. It's hard to see, but there is a screw buried down in here that I cannot reach unless I get at it from this angle. So I'm going to have a hard time getting the clamp open to get that capacitor out the way it's in there. There are two other screws that go in that might, they have nuts on the other side, so you have to hold the nut on the back, unscrew it, hold that nut on the back, but then the tubes are in the way, you got to take the tubes out. So it's a pain. So maybe I'll just leave this here, and I'm going to glue these with hot glue in here to hold them in place. Somebody's going to say hot glue is going to, you know, could melt, which is true, but that's okay. The wires are going to hold them in place pretty much. I'm just using the hot glue to give them a little extra hold. Okay, we're going to try to pull these wires off and make sure they stay together so I remember where they go. No, they don't want to stay together, but that's okay. Alright, and then we need the ground from there. Pre-tin. Get a piece of heat shrink. And this is always a trick, trying to solder 3 wires together at the same time. So what will happen is one of them will fall apart while the other 2 are being soldered, and then it'll just be a rat race trying to get them all soldered at the same time. So I'm actually going to cut a little bit of this lead off and then use this to pinch the wires. Hopefully they'll stay together now. Okay, one problem, I want this to be straight like that. Okay, snip that off. Cool a little bit. Stuff that heat shrink over it. And then we'll go ahead and heat melt that on. Or heat shrink that on. Tried to make this long enough to reach all the way over here to that side of the capacitor. It's a little bit of a stretch. I might just stick these down here and make a wire go there instead. We got 2 of them to do, so I'll go ahead and start on the second one. Nice thing is there's only 1 wire going here, so that makes it a lot easier. And this is confusing, I admit, because they used brown wires here on the red dot. So these brown wires are actually positive, and they're high voltage positive. They're not playing around. So sometimes you got to keep your eye on the colors here. I used red, they used brown. So, and I used brown for negative, so that's why it's confusing. I'm still going to stick to my brown for ground for 0 volts. Then we're going to pre-tin the wires like before. And get a piece of heat shrink. That didn't quite shrink. That didn't quite finish cooling. There we go. Now, if I was thinking ahead, I would have pulled out one of these guys and stuck them in. There's a little 0.1 microfarad capacitor that I think will help get rid of some of the high frequency noise. And the question is, where do I put it? Do I put it on the first one? Do I put it on the second one? Do I put it somewhere else? I'm just going to put it on this first one here because I'm working on this one right now, so it's a little easier to get it on there. But wherever you can clamp noise out, it'll help. Again, always pre-tin the wires, no matter what type it is. Get that one cold. Now we can try to get 3 wires in one spot, which I said is hard, and it is. Probably not the smartest idea. It looks like it'll work. Okay. Pull the heat shrink up and go ahead and shrink that in place. There we go. Good heat shrink. Okay, these two negatives are going to be attached together, just like they're attached together on that capacitor. They're common negative. And we need a section of wire here, because it's such a short piece of wire. Go ahead and get that ready. It would have been a lot easier to just solder the capacitors on top of this capacitor, but this is so old I don't trust it. I've seen some of these things basically catch fire, so you don't really want to reuse the old capacitor. They're 60 years old. They're they're beyond the end of their life. They're not meant to last that long, so it's a big risk probably if you're going to run with the old capacitors in place. And it's very, very expensive to buy multi-section capacitors. You can still get them, but they'll cost you $50 for one of those. These are about $1 each, and they work just as well. Alright, I didn't pre-tin this wire on purpose because I was bending it around the other things, the other leads. So I'm going to have to just put a bunch of solder in here, let it soak in for a second, and then we're good. Got to cool still. And kind of bend this in place, bend this into position so that we can put a heat shrink on it. I like my heat shrink. Let's put a big one on there because it's a big joint. This one I'll pre-tin this wire. And melt it right in place here. It's okay to have one wire, this capacitor, connected, because that doesn't do anything. So the one I'm leaving connected is the ground wire, the 0-volt one, which ain't going to shock you, it's not going to catch fire, nothing like that. So then we'll probably hot glue these in place later once we get everything working. Alright, so that's the big one. Let's see. This guy in here in the corner is going to be really a pain to get to. This little silver one down in there. But let's see if we can pull it off. Okay, this was 1 microfarad, 150 volts. This one says 3.0, 100 volts. So 3.0 in this case means 3 microfarads. But it's only rated 100 volts, but remember that's the one we tested. and it just kind of barely went over 100, like 105 or so, and then it dropped down to 69. So I think this will be fine on a transient like that. We'll go ahead and take the chance with it. So this is a electrolytic, so it has a plus on it, and if I zoom in you might be able to see that little tiny plus, maybe. Yeah, there he is. A little tiny plus mark on that capacitor, which means it's polarized. It has a polarity. One side has to be positive or it blows up. This one is non-polar, so it doesn't matter which direction it goes in. So that makes it a little easier. So we're going to go ahead and we can just snip the old one out and put the new one in, and we don't have to worry about the orientation. We do have to make sure we get it in the right place, however, so we have to plan that a little bit. Luckily these leads are plenty long. Snip those down to a reasonable size. Tin them. Okay. And I'm going to go ahead and try to snip this guy out here. Gotta keep attention though. Remember which two places that was connected. If you connect it in the wrong place, something blows up. And you probably don't want that to happen. See, it's only one screw to get this out, so we'll take this panel off. It'll be easier to get to the other parts. Alright, 25 microfarads, 25 volts. Grab our bag. The little guys. Again, these also have a positive and a negative. Camera's not focusing. Alright, well, there's a tiny minus mark there, and a long one is plus again. And these ones, we can just do this with the leads and solder them in, so we don't need to use all that fancy heat shrink tubing and covers and stuff. So we got to pay attention again to where these are. Positives on the bottom, so snip that, lift it up. We'll go ahead and put the positive on first. As always, we're going to pre-tin the leads. So they stick. Okay, make sure we get positive on the positive. Okay. Go ahead and hit the negative here. Take a look at the back of this. It's a little hard to see. Maybe I'll snip it out first. See if we can get this thing to focus here. So the back of this guy is pink rubber, and it's hard to see here, but it's actually bulging, which means this thing is shot. I mean, that thing is close to exploding probably. It's not really going to explode that much. It's only 25 volts, and it's probably only putting maybe 3 volts across it, but that's not a good sign. The thing is dead. So we replaced it. It's gone. Tin another one up. Again, keep track of which one's positive because you got to get it right. Tough to get the iron in here the right way. Looks good. Snip the old one out. Same thing, pink stopper looks horrible. 25 microfarads, 25 volts. Just double checking that on each one of these to make sure I've got the right capacitor. This one's a little tighter spot than the other ones. It's going to be hard to even just warm this one up without burning myself. Put a little extra solder in there to carry the heat. I'm going to have to get rid of this guy too because I can't really get in there. Just leave that soldering iron long enough that you can see all the solder melting around it. That's how you know you've got it soldered well. And then double check it at the end, just pull on it gently. Phew. Alright, one more here, I think. Pre-tin. That's garbage. Let's see, how am I going to get to that one? Alright, so this is the guy here hiding in a piece of funny fiberglass stuff. Pull that off. That's just to insulate it. And the negative is right there where I clipped it, and the positive's in the back here. And I'm going to have to clip both of those to get the thing out of there. Get the new one in. And let's double check the value. Alright, see, I'm glad I checked this one. 3 microfarads, 350 volts. It's not auto-focusing. There we go. 3 microfarads, 350 volts. So we need to get a different capacitor to stick in there, because our little 25 volt one is going to blow up. Alright, so I went back and tested the voltage across this capacitor that says 350 volts, 3 microfarads. And lo and behold, it only peaked at about 60 volts and then came back down to 50. So I'm going to say it's not going over about 60. So I can go ahead and use another one of these really good polymer caps, which is also 3 microfarads, so it's exactly the same capacitance. And although it was only rated for 100 volts, but it seems like that's fine. So we're going to go ahead and use this one. Again, this capacitor is non-polar, so it doesn't matter which side I hook up to what. I guess I'll stick with my convention for brown being negative. Looks good. Okay, I think I have switched out all the capacitors on here. And this is only one amplifier. There's still another one. But we should test it first. And make sure it's working okay. While I've got it open, I should probably spray these pots with some cleaner to make sure that they're working right. And switches are sealed, so I can't do anything about that. These jacks I can probably spray with some cleaner on the backside also. So this is the Deoxit fader cleaner. It's the gold standard for cleaning stuff. All the technicians use it. So I'm just going to go ahead and spray a little in there and exercise this a little bit. Hopefully there won't be any crackling. I think when I tested this last, it seemed like there wasn't any crackling anyway, so it's in good shape. This pot looks like a sealed one, but the switch on the back I can spray. Okay, the switch is open here. So there's a switch right on the back here that's hard to see probably, but I just sprayed those contacts there. This one, there's a little gap that I sprayed in, and up here we've got some jacks. May as well spray in these little switch contacts here. Notice how those are doing. Let's see, there's another one there that I can't quite reach with my finger. And One more up here. Should probably just get this from the other side. And I think that's about it here, so just exercise these a little more and go test it. One thing that we want to do before we forget is to pull these tubes out and reseat them a couple of times maybe. Wouldn't hurt to test them. They're stuck in there pretty good. Alright, 12AD7. We can clean these off gently with water and a paper towel. You don't need to do anything too crazy. They're happy like they are. You have to beware once you start rubbing these with something though, the paint will probably wipe off. Water I guess is okay. And probably pulling these out and sticking them back in will be enough to clean the contacts well enough. This one's got a bent pin here. Hopefully the other ones won't give me this much trouble. Something about that third pin just doesn't want to go in. Alright, I'll come back to that one. Let's see about this guy. This is 6BQ5, which I think is the same as EL84. So made in Japan, it's original Japanese made tube by Hitachi. These guys are in there good. Made in USA, so this one's been replaced. I think that this is the rectifier tube. 6X4 it looks like. Yeah. Very common rectifier tube to transform AC power into DC, so that's part of the power supply. This one's got a shield on it, so this is the preamp tube. Boy howdy. Oop, just lost that one. Take a couple minutes to clean the front of these while all the parts are off. Just a damp rag, not wet. And my simple green is up here, out of the baby's reach. In the case, there's plenty of spots that we didn't get because we had the amplifiers there, so we'll go ahead and clean this up. Some dust out of there. Okay, the tricky thing here, putting this back together for testing, is that I put it in, I took it apart backwards. You're actually supposed to put this thing in first, and this thing flips a switch down in one of the amplifiers, so we need to get this back in, and I have to remember which screws it was. These two. Baby Ryan was down here and he kind of mixed up some screws, so This arm is a little bit adjustable, so I shouldn't have taken it off because it was adjusted correctly. However, I can see where the screw mark was on the original one, so we could try tightening it there and see if that does what it's supposed to do. If not, we'll have to open it up and adjust that screw a little bit. Okay. Flip this around. Let's see, we got too much slack on this wire here. And we have to plug these two wires into the speaker, which I can't do from this side. I have to do it from the back. And now we lay, let's see, it's tempting to put the amplifiers in now and hook them up. The problem is you can't hook them up from the front, you have to hook them up from the back. So we need to screw the front plate in first a little bit, just so that we can go ahead and get the amplifiers in. Left goes on top, as I recall. We'll have to put some screws in here. Tricky thing are the connections. I think I can get that one in from behind, but we'll find out. Insert your favorite joke about Japanese cars being hard to work on because they're like puzzles, and that's about what this is. This is one heavy beast. Okay, so it looks like I might not be able to get this jack in because it ended up on the wrong side of the metal piece. So I might have to take it apart again. There's another switch here that I missed. I need to clean this one with the spray cleaner. Anyway, and then it's just a matter of figuring out where these things plug in. So I got to take the left channel, the top one out again, just so that I can get the connector on the right side. And while I have it out, I'm going to spray it with that cleaner. Very hard to reach the back of the switch. Okay, now let's see if I get lucky this time. There we go, I got lucky that time. There are a lot of little things to connect in here. I should probably try to get a better camera angle, but even that might not work. So there's a little 4-pin connector. And we have this, which picks up the signal from a pickup. And then there's this, which got snagged in here somewhere, which plugs right into here. Probably need to make sure that wire's not somewhere bad. And there's this wire, which needs to go here. And I think I got all the wires now. I believe I got all the wires. Except for the speaker, which is up here. Speaker Pins are hiding right under there, so this one you have to just slide right in. Thankfully that just slides right in very easily. Tolex is peeling inside there, so it's difficult. Okay, I think we're ready to turn this thing on now. Here we go. This is a reel, and then you take up reel. And we'll take this tape, pull it across, pull it over the heads here. I'm missing a piece which is on the front panel. Front panel has an extra roller here, which I'm missing. I hope that's not too much of a problem. I've got the power on already because the switch got bumped. Okay, this goes here. Gotta get a little extra slack so we can get up into the reel here in order to start rolling it. I have to go around at least once. Okay, turn amp on, and probably before we turn it on we should check to see if the tubes are lit. Well, if you ask me, I'd say I don't see any of the tubes lit. Oh, because I have it on amp off. Turn it to all on. I thought it was amp on, but it's amp off. Okay, now they're lit. 1, 2, 3, 4. I can't see the last one because it's in a shield. 1, 2, 3. I can't see the last one because it's in a shield. But let's turn this on. Turn the volume down a bit. And go ahead and hit play, which is this one. See if we got any sound. We got some sound on the right channel. Oh, I'm not getting that channel because the selector needs to be adjusted correctly. Let's see, what's this stereo? Stereo, monaural, 1, 4, and 3, 2. I don't recall what all those are. This stereo shows 2 lines, that stereo shows 3 on each side. Have to read the manual. Sounds like I'm getting signal from the left channel, but it's not showing on the meter. The right meter is showing, but the volume knob doesn't seem to do anything. I don't know if that's a effect of it being in stereo or mono. Take up reel might be slipping a little bit because I see some slack once in a while. But it's working.